Today you're going to hear from me. I'm Jim Smith. I am the LANDFIRE team leader for the Nature Conservancy. After I talk about the context of the program, sort of the past and the present and the future, Inga Puma, who is the LANDFIRE technical lead with the EROS contractor KBR, will go into some examples, particularly I think focused on some of the fire and fuels products of some of the current situation of the LANDFIRE products. Then Randy Swaty, who is an ecologist on our TNC LANDFIRE team, will then go into, I think, some interesting examples, some applications of the LANDFIRE data that we hope you find interesting. So we'll be switching a couple of times, so hopefully that will go well. And we really appreciate you being here. So first of all, context, what is LANDFIRE? Most people have heard of it. It's an interagency multi-partner program that basically is a data creation program, trying to create a database for the entire US that has information about vegetation, fire, and fuel. The primary partners in this program are the US Forest Service, particularly the Fire and Aviation Management Branch of State and Private Forestry, the US Department of the Interior, Office of Wildland Fire, headquartered in Boise, Idaho, and then the Nature Conservancy's North America region, where Randy and I live with the remainder of our TNC team. And then also the USGS EROS Data Center and Contractors. So these are the groups that are primarily involved in the LANDFIRE program. So the past, let's just talk a bit about the past, because we do have to understand this to see how we got to where we are and where we hope to go from here. So I think I'm going to turn on my video just to make sure that my bandwidth doesn't get used up too much by video. So LANDFIRE began in 2004 after the National Fire Plan, based on a charter from the Wildland Fire Leadership Council. And it's a long charter, but I sort of boil it down to what I call the 4 C's. So LANDFIRE is required to be comprehensive. And that means every acre in the continental US, in Alaska, in Hawaii, and the insular areas must be covered by LANDFIRE products. The products should be compatible. And that really means that they're as easy to use as delivered as possible, because they all match thematically and geometrically. So you should be able to use them almost instantly as they're delivered to you. The products need to be as current as possible, given the resources and methodologies that are used to create them. They should be current. So we need to update them or recreate them periodically. And then finally, they should be as consistent as possible. And the consistency is always kind of a hard thing, because you're thinking about mapping Florida and Alaska and Maine and, you know, everywhere in the US, American Samoa. But we do try to use similar processes and data sets everywhere we can as possible. That is across geographies as well as across time. Now, our consistency across time has wavered a bit, mainly because we've been trying to improve the product. So when you go to look at versions, and there are several versions, our consistency across time is not perfect, but we would certainly like to communicate with you if you're going to compare across versions. And we hope to be even a little bit more consistent in the future, that we've stabilized the processes a bit. So these 4 C's basically define how, when, and what we create. We've created about a couple of dozen current and historic vegetation spatial data layers, fuel, surface, and canopy, ecological condition, all 30-meter spatial data layers, multiple versions. And we've created somewhere in the 800 to 900 number of quantitative state and transition BpS models and descriptions. And we'll get into more of that later if you're not familiar with those. We've delivered versions circa 2000, 2001, the original product. It was updated 4 times to reflect 08, 10, 12, and 14 landscape conditions. And now LANDFIRE Remap, which is intended to reflect landscape conditions at the end of 2016, except for a few products, which I will mention quickly later on. So I don't expect you to read this, but I think it's important to see that this is a Herculean effort, in effect, that the rows on the left represent all the products that LANDFIRE delivers or has delivered. The columns across the top, You look at starting at least in about the 4th column, all the way to the right, represent the different versions. And the little letters in each box represent the different geographies. So it's a lot of products over time that have been created and delivered and made available. And things have changed a bit. And I put the red square down here in the right, so you see there's a funky character here. And basically what's happened now is instead of delivering these as separate spatial layers right now, because they are derived as an attribute of the biophysical settings, the information is now provided in that particular layer as attributes. But that information is still delivered, it's just in a different place. But we are considering whether or not now to create those spatial layers again, just for convenience of the user. But this just demonstrates the variety, the depth of the products that LANDFIRE has created in the past. So where are we now? Well, Remap for CONUS and Hawaii is complete. All products for those 2 geographies are now publicly available. Alaska and the insular island territories are underway. And if you don't know what those are American Samoa, Guam, Puerto Rico, Virgin Islands. So there's a few islands that we're also required to also produce products for. So CONUS and Hawaii are complete. You should find them on landfire.gov. They can be downloaded here. What I'm showing is a screenshot of the LANDFIRE data distribution site. There are other ways to download data as well, but I'm not going to go into that today. We can certainly help you if you need to have some other way to access the data, including a streaming service that LANDFIRE provides that we can direct you to. So what's remained the same in LANDFIRE Remap? Well, we still have the same 4 C's. We still have the same criteria and constraints. We try to be current. We try to be consistent. We certainly try to be compatible, and we try to be comprehensive. They have a tangible impact on what we can do, those constraints. The basic product suite is still the same. You don't see a lot of additional rows in that table that I showed you earlier, but there are a few additions. It is important to understand that some things may have changed in content because we're trying to improve the product quality. And I'll mention a couple of those in a few minutes that I think may be of interest to you. So the basic product suite is about the same, but there are differences through time based on the idea of improving the usability of the product. What is also not changed is that LANDFIRE should be considered a large landscape, regional, national data set as delivered out of the box. We hope that we present the right types, patterns, content when you look at a large landscape. That's a hard thing to define, what a large landscape is. It means something different in Wyoming than it means in Alabama. But that is how we define the application scale of these products. But as you use smaller and smaller geographies, you should be expecting to make alterations to the data to make it more reflective of smaller and smaller geographies. That is just an expectation you have because of the way LANDFIRE creates its products, the way it delivers them, the time frames, the methodologies. That is how you should be expecting this data to be delivered. So what's new in Remap? Well, we've changed how we geographically map to be more ecologically relevant. Instead of using NLCD map zones, we now map vegetation based on what are called Omernic level 3 ecoregions, which are more ecologically relevant. So we have fewer seam lines between the areas that we map as individual blocks. We also now map in terms of tiles. So we hope that we have a lot fewer seam lines and sort of odd transitions in the data based on these new footprints. There are new pre-processing methods for imagery that we use that create an improved and a more consistent image base, such as the removal of clouds and shadows and things like that, and creating a very consistent image base. Remember, the products are all based on some sort of satellite imagery, so it is important that we have a good image base. We also spent a lot of time over the past few years improving what we call auto keys. Those are, in effect, sort of computer programs like dichotomous keys for reading the vegetation plot information that is provided to us to drive the mapping and assigning that plot to a particular vegetation type. We have more than 1 million plots. You can't do all that by hand. Many of them don't have an assignment, so we have to do that, and we do it consistently using these auto keys, and we think we've improved those. No program is perfect, but we do think they're better than they used to be. So we have better plot data to assign our mapping task to. We do now have Landsat 8 imagery, which we did not have before, which is an improved quality of image. No more line scanning problems or things that we had with 5, or the fact that Landsat 7 died. So this does provide us with a better image base than we had in the past. And our production schedule, we actually factored into the production schedule during this particular cycle, external review of the products by non-LANDFIRE program staff before they're actually delivered to the client. And we do believe that that has helped us, find some obvious errors and actually improve the quality of the product. And importantly, we've had 15 years of experience at this. We hope we've learned a lot by it, and that will make our products better. But key to this also is we have 10+ years of feedback. And actually in the Northeast, we had a really lucky situation where we had a Northeast liaison, Megan Sabaski with the Wisconsin DNR, and her colleague, David Kojaleski. They helped us link to people in the Northeast geo area to provide data, to provide feedback on things that needed to be corrected. So we hope that that also has helped make a better product. We have many more field plots, and we do credit Megan and David a lot for really connecting with you, users in the Northeast geo area, because we didn't have a lot originally. We have a lot more now, and they're a lot more diverse, and that is really critical to making good remotely sense-based maps, as having a good field base. So thanks to all of you who provided plots, and thanks to Megan for coordinating that effort. We were able to incorporate LiDAR in a modeling process to improve the thematic resolution of the structure products, the cover and height. And again, I'll demonstrate that later so that you can actually see what that means. We conducted a multi-year review of the biophysical settings, models, and descriptions. Randy is going to talk about that and what those are and how they're being used. But we were able to review those and actually clean up that set, make it more consistent, and make it, I think, scientifically credible based on the updates that we were able to make. Here's where we have a couple of new products. We have a new way to provide disturbance, which is what we call historic disturbance, which actually combines the disturbance over the past few years that may have occurred on a pixel. So if there were 2 or 3 disturbances in the past, annual disturbance layers would have contained it, but the compiled disturbance layer only would have had the last disturbance on that cell. Now we have a coding system in there that you actually see the last few disturbances that might have occurred on that spot. And we also create something now called year capable fuels products, where, remember I said LANDFIRE products largely represent the landscape at the end of calendar year 2016. Well, because that's 4 years behind, fuels people needed to be able to have a more current product. So we were able to actually advance the fuels models, the surface fuel models, over time using transition rules so that they reflect the year of delivery. So you will actually see 2019 fuels products as well as 2020 fuels products, where fuel models in disturbed areas have been moved to be more current. So that is a new product. So look out for that and make sure that you understand that. We also created and implemented a new backwardly compatible fire regime group schema. Many users across the country thought that the fire regime group schema, which came from the fire literature, LANDFIRE did not invent it. We just basically adopted it, but they felt like it wasn't particularly useful. So we actually created a new one that we hope is more useful. And this is what the new fire regime group schema looks like. So there were originally 5 fire regime groups based on fire return interval and the percent replacement fire. In other words, what's the severity of fire? So we were able to break those up, and we did a cluster analysis on data to actually see how to break this up. So you'll see more resolution in the fire return interval now. So instead of it being 0 to 35 for fire regime group 1, it's now 0 to 5, 6 to 15, and 16 to 35. Provides a little bit more data richness for you to use if you happen to use fire regime group in your planning. So what about the quality? We know that there were issues with the quality in the Northeast. LANDFIRE was actually called a barrier to fire in the Northeast area by the Northeast Cohesive Strategy group. And so we did work hard with Megan's help in particular, and hopefully with your contributions, to actually improve that. We do publish and make available assessments of the quality for the vegetation maps in 4 different ways: ecological systems, National Vegetation Classification Group, NVC Macro Group, and SAF SMRM cover type. Those are available for download. So if you use the existing vegetation type data, you should get some idea about the quality based on those products. We actually withheld about 10,000 plots from the mapping process in the Northeast to use as an independent testing site. We provide a traditional contingency table. We also provide an example of how to collapse categories in the contingency table. And I'll show you why that's important in a minute. But the traditional contingency table is just a cross tabulation at the withheld, those 10,000 assessment plot locations. What did the plot say it was versus what we said it was on the LANDFIRE product? So it's just a cross tabulation. And in this example here, you'll see there were 235 matches where the plot database said it was Laurentian Acadian Northern Hardwoods Forest. And our map also said it was Laurentian Acadian Northern Hardwoods Forest. So there were 235 matches. The major diagonal of a contingency table represent the matches. Anything that's not on the major diagonal is an error, is a mapping error or a mismatch. The problem with the contingency table is in the Northeast geo area, it's 194 rows by 194 columns. It's pretty hard. I mean, all the information is there. If you want to zoom in on a particular spot, you can, but it is kind of hard to use that in a really practical way. So what we provide is a way, if you use a different category system, say you collapse all the coniferous systems into just a conifer group, we show you how you can collapse the contingency table so that you would have some estimate of what the quality of the LANDFIRE data was in your classification rather than in LANDFIRE's classification. We also provide something called a category agreement table, and this is unique to LANDFIRE, where we basically collapse a row in the contingency table to just a few columns to make it a little bit easier to interpret. So every row, every system that had an adequate sample for assessment is listed in this table. So this happens to be Laurentian Acadian Pine Hemlock Forest. We know that we mapped it directly from the LANDFIRE reference database. That's what data source means, because we take some categories from, say, Cropland Data Layer, National Land Cover Database, Urban, and things like that. We don't map everything. Some things come from other sources. This column will tell you that. There were 219 plots that we could use to assess that type in the Northeast. The row agreement, in other words, how many of those matched, was 52.05%. So about half the time the LANDFIRE map matched what the plot database said it was for this particular type. That's why I think this is important, because it zeroes in on types and allows you to tell how good this map was on the types that are of interest to you. Importantly, we show you what was the primary error. Sometimes it's not next to you in the contingency table, so it's hard to find. So we find that for you, and we show you that the primary error that we made for that type in this product was Laurentian Acadian Northern Pine Forest. So it's another coniferous. That may be important to you, maybe it's not. That's for you to decide. We can't decide that for you. So you combine those two. So if you said, for instance, that was not important, the agreement for this combined type would go up to nearly 67%. And just for context, if you go to NLCD 2011, which is the latest accuracy figures I could find for NLCD, they map 3 forest types only: deciduous, evergreen, and mixed. And their agreement, their accuracy for coniferous types was 68%. So you can see this is somewhere in the ballpark, but it's up to you to decide what's good enough for you. We cannot do it. We try to provide you the information that will help you make that decision. We have not done it much in the past, but we are hoping to perform a statistical assessment of the cover and height products and try to figure out a way to actually assess the fire behavior fuel model, surface fuel models, which we have not done in the past, but we hope to do in the future. So that's where we are. Where are we going? Well, as I said, CONUS and Hawaii are complete. Alaska and the territories are underway, probably completed sometime late spring, early summer of calendar year 2021. Remapping is expensive and it's slow. It's more expensive and it's slower than updating. We don't know if we're going to be able to conduct another remap in the future. It's going to depend on budgets. It's going to depend on product quality. We're not necessarily counting on that. So our strategy right now, what we're really trying to do is to find out a way, determine a methodology that will allow us to provide more frequent updates annually, we hope, with decreased latency, perhaps only a few months latent. So disturbances that happened in the fall of 2020 could show up in a product in the spring of 2021. That's what we're shooting for now. We've moved to that. We're trying it now. We're going to see how well it works. So the goal is to decrease latency while keeping product quality satisfactory for the kinds of applications that are most important. So that's where we're headed. All right, so Northeast results. We're going to focus now between myself and Inga and Randy on some things in the Northeast to show them some real examples of the products. We had a strong desire to improve the quality of these products in the Northeast based on the feedback that we got. We got a lot of really specific and useful feedback from folks in the Northeast geo area through Megan and otherwise. So we really appreciate that. It's really key for improvement for us to get good feedback. One of the things we did was we improved the structure variables by increasing the thematic resolution. So in the original LANDFIRE and all the updates, we only had 5 bins of tree height. For instance, 0 to 5 meters, 10 to 15 meters, 25 to 50 meters, etc. Well, in LANDFIRE Remap, we're providing 1 meter height estimates instead of multi-meter bins. 0.1 meter for height on shrubs and grasses up to a certain height, not all the way up. Instead of 10% bins for existing vegetation cover, we're now providing those to you in 1% bins. So what does that mean? So I just randomly picked an area. I know this area, so I went here. This is the northern end of the Shenandoah Valley, Massanutten Mountain, for any of you that might know this place, just to the west. Over here, clearly in a Ridge and Valley province. And so I'm going to zoom in on this so that you can see the difference in the products. And I picked this area because it's identifiable to show you that it's the same area. So on the left is the 1% cover bins. On the right are the 10% cover bins. You can see there's a lot more information here in Remap than there is in 2014. Doesn't mean 2014 is wrong, it's just this data is richer. Here's what vegetation height looks like. Previously, pretty blocky, pretty sparse information, few artifacts, but the new process has allowed us to clean it up a little bit and to also provide more height variation in here, which is, we know how these forests are. There is height variation in there. All these trees on the right, they are not the same height. So we hope that this provides additional information. It allows you to cut and slice the height and crown cover data, canopy cover data, however you wish, instead of being restricted to LANDFIRE categories that we provide. So I'm going to turn it over to Inga now to talk about some of the fuels changes.
Thanks, Jim. Yeah, the height and I mean the richness of that data is awesome, and LiDAR contributed to that a lot. So if you are involved in LiDAR data in your state, you know, keep encouraging the collection of LiDAR data for sure. So I'm just going to switch over to talk a little bit about the fuel model changes that we were able to address. One of the things we have a suite of, you know, basic vegetation products that Jim kind of covered, but we also have that for fuels, and those are essentially based on the vegetation products. And we have the 13 Anderson and the 40 Scott and Bergen fuel model designations, and those give us an idea of the rate of spread and flame length and things like that for different types of vegetation cover and height. And so a lot of the hazard models that we see use LANDFIRE fuel model inputs. So these are typically the surface fuel models and the canopy attributes. So one of the things that when CPAW came to town, so the Community Protection Against Wildfire Program, they came down to New Jersey, which is where I'm from. I'm quite involved here. And they ran the FSIM model to get their hazard estimations for this area of the Pinelands in New Jersey. And when you do those FSIM fire behavior models, you get an estimate of burn probability and flame length, and you kind of just multiply those together to get your hazard. So what we noticed, and this graphic is from Eva Carroll out in Missoula, she created this, but we noticed the first time she ran the FSIM model with the LANDFIRE inputs, that middle frame there for flame length was basically 0 for the entire pinelands of New Jersey. So mostly pitch pine dominated systems. And so that didn't look right. And what we found out was that essentially, because we have the pitch pine system designated as shrub surface model, the shrub surface model typically doesn't include canopy. And the reason it was designated as a shrub surface model originally was because that was the kind of rate of spread that, you know, we needed for that system. And so we were, you know, there was some concern is if we add the canopy back in, is that going to really slow down the rate of spread for that vegetation type? And you know, we went ahead and with our fuels team at EROS, we went ahead and just tried some different fires and just to see, you know, what it looks like. And we had a group of folks that are experts in fire and pitch pine in the Northeast, and had a call and basically found out that, yeah, you know, we could go ahead and add the canopy back in, and we're still going to get the kinds of rates of spread that we need, but we're going to get the flame lengths that we need to feed into these hazard models. So so this graphic here is showing after you can add in the canopy, you see that the flame lengths make a lot more sense. And then you get a better estimate of your hazard with the pitch pine ecosystem. So that was just one kind of specific change that we made in the Northeast, trying to involve folks from around the region. I did want to point out that the red along the coast there, because I'm going to talk about that in a minute. Okay, go ahead, Jim. So you can see here on the right for LANDFIRE 2014, when you look at the canopy height layer, there's a lot of gray there, and that's where we had the shrub model and the canopy height was not coming in. So once we did include canopy and with the shrub model, which is possible now, you know, you could see that a lot of those gray areas were filled in. So we have, you know, trees there instead of just shrubs, which is how it should be. Okay, go ahead. Oops, wrong way. There we go. So this area is, you know, you might recognize it as like where 70 and 72 come together if you're familiar with the area where the Wawa is. And you can see that, yes, now we actually have canopy cover in that area. So, you know, these are, you know, important things when you're running those fire behavior models. Okay, go ahead, Jim. So another issue we had, and just to kind of orient you, that river there is the Mullica River, comes out into the Great Bay, just north of Atlantic City, but there's quite a bit of salt marsh in this area. And it's predominantly like a sort of a high marsh dominated by Spartina patens, which is also called salt hay. And historically there have been fires in the Salt Hay area, but it's an interesting, you know, that doesn't happen as much anymore because people don't farm salt hay. In any case, much of this area was considered the GR8 fuel model, which you can see there. It has a very high load. It's coarse, it's the humid climate grass, but you know, it tends to be much taller. If you look at that picture there, the Phragmites in the background is kind of what, you know, was thought to be in that area with that really tall reed in the background. And in actuality, it is that shorter Spartina patens in the foreground. And so this whole area, which you saw was sort of lit up red along the coast, had that more of that Phragmites fuel model assigned to it in LANDFIRE 2014. And so we went ahead and adjusted that down just a tad to represent the height of the Spartina, which is actually there along the coast of New Jersey. We really only have the Phragmites when you're getting close to you know, the more disturbed areas, but that most of that shore there in the back bays is Spartina. So we were able to adjust that, which is great. Okay, go ahead, Jim. So there you can see some of the changes. On the right is the where it was GR8 with the brown, and then on the left is changed to GR5. So it's just a little less crazy in terms of the flame lengths, which is great. Okay, go ahead, Jim. So the other thing that we were able to incorporate were was the fuel calibrations that were conducted in concert with the Northeast risk assessment that the U.S. Forest Service is doing, and that Megan Sabaski and Brian Schaffler helped sort of organize in Albany, New York. And for the most part, we were able to incorporate most of the calibrations that came out of that workshop. So there are approximately 33 vegetation types addressed during the workshops, and we adopted just all of them but two, and those two were, you know, some ruderal and an agricultural type that were the same across the entire country, so we couldn't change those. And generally, the surface fuel models that were calibrated by folks in the region tended to increase the fire behavior. So, you know, your hazard results would increase. But in some of the hardwood EVTs, the fuel models reduce the fire behavior. So it was a mix, but for the most part, you guys tended to have a more extreme fire behavior from these calibrations. And then 13 of those 33 vegetation types had sort of, you know, during the calibrations, people say, okay, well, the canopy base height is typically this. But that's not something that we could incorporate because we do have a across the board calculations for canopy base height, and those are derived from the forest vegetation simulator, the FVS scenarios for our region, and those are all based on the vegetation type, cover, and height on a regional basis. So we weren't able to just sort of hardwire the canopy base height in there, but we were able to incorporate quite a bit of what came out of that those workshops. And that's all I have, I think. So I think I'm going to hand it over to Randy.
Are you on mute,
Right
Randy?
here.
Oh yeah, I said all kinds of profound things. Thanks for that. And I wanted to amplify thank yous that Jim delivered to all you guys for participating, and also a couple of shout outs. Another shout out to Megan Sabaski, who put so much work into the remap effort in the Northeast. Really changed things. Incredible. Thank you, Megan. And a shout out to Inga, who's relatively new on the LANDFIRE team. Great to have your knowledge in depth. So thank you both. And I'm going to talk about the biophysical settings review. Some of you may wonder, what is a biophysical setting? It's basically a representation of historical ecosystems for the United States. Each biophysical setting has, associated spatial data, models, which I'll talk about in a moment, and a text description that says what this sort of goes over what is in the biophysical setting. And so I'll talk about these 4 bullets briefly for the Northeast. Okay, so here's a map sort of depicting the results of the review that we started back in 2015. So for each one of these polygons, which are LANDFIRE map zones, there's roughly 25 to 30 biophysical settings. And you see in Western New York, roughly 35% of those biophysical settings receive some review of some sort. It could be a total remap of remap. It could be a total revision of the description and the model, or it could be just editorial comments. So the review results varied in intensity for each biophysical setting that did receive review. Then looking at it another way, luckily, the biophysical settings for which we did receive review covered a lot of the Northeast. So you see that here, basically the gray pixels represent biophysical settings or areas that did not receive review. And the colorful pixels represent biophysical settings that did receive review. Too many R's there for me to say. So anyways, spatially looking across the area, you guys, great. Great to see so much review. So the models. So each biophysical setting has an associated model that represents historical disturbance regimes and the succession classes. So I'm going to talk about that for a second, then jump into the succession class bit. So on this diagram, you see kind of a schematic of an oak ecosystem in the Northeast with 5 succession classes represented by the blue boxes. Our modeling gives us those expected percentages of the succession classes that would have been on the landscape historically. So for this oak ecosystem, roughly 60% would have been in the oak forest succession class. And you see it says closed at the bottom. That's just a very generic label. For this oak forest, I think canopy closure maybe goes up to 70%. So it's definitely not like a closed canopy forest for, say, northern hardwoods. We did not try to map where these succession classes were historically because we assumed they moved around, but we did develop rules to map them on the landscape today so we could find out what percentage of this oak ecosystem or others are in the different succession classes. The succession classes for mapping are largely defined by canopy height and canopy cover. So I just made up some rules here. I didn't look this up. These are just ones I made up. So if the savanna, is defined as having tree height of 5 to 10 meters, canopy closure of 30 to 60%, and we see that combination in our data sets, then we would give that pixel a label of savanna, which would it would be a letter name, such as B, super meaningful letter B. So importantly, we upgraded and filled in gaps for the succession class mapping rules. We found that for some biophysical settings, there were combinations that were not attributed to a succession class. For example, maybe 20% canopy closure was not attributed to one of the succession classes for this oak ecosystem. In that case, it would get labeled as uncharacteristic. So we made sure to review all those gaps and make sure that they were legitimate. And we also added a leaf form category to succession classes. Sometimes height and cover were not enough to distinguish succession classes when mapping, so we added in leaf form, broadleaf, coniferous, mixed to help with that. So the resulting data table for this was like 10,000 rows. It was a lot of work led by our colleague, Corey Blankenship, and with feedback from many of you guys. I wanted to jump into an example, and it's one that I guess I got kind of lucky in picking because it's pretty dramatic. I didn't pick it on purpose. I just kind of picked the top one, biophysical setting that received review. And it was the Central Appalachian Dry Oak Pine Forest, which covered historically roughly 14 million acres as mapped by LANDFIRE. For this biophysical setting, you had in the description chestnut oak, Virginia oak, eastern white pine, white oak, those species. And here is one result of the review. On the y-axis, you see different fire regime types: surface, replace, mixed, and all, which is sort of a combination. And on the x-axis, you see fire return interval in years. The gray bars represent the fire return interval for those fire types from the original biophysical settings model. And you'll notice that, for example, the surface fire return interval in the original LANDFIRE model was roughly 175 years. Review reduced that down to around 15 years, which I think is much more appropriate. It matches the current literature. It matches what we think we all know about this type. Looking at this another way, if we sort of multiply the return interval times the acreages for biophysical settings, we can get an estimate of the annual area burned or blown over or flooded, wherever the disturbance is for that type. Using the original model outputs, we would estimate that roughly 100,000 acres of the Central Appalachian Dry Oak Pine Forest would have burned annually prior to major European settlement. After review, that bumps up to almost 1 million acres. So you may be asking why the big change. And I happen to have picked one that was kind of dramatic. This is not illustrative of all the results from the review. This particular biophysical setting, the description and model, I think were almost placeholders from the past. The description was pretty solid, but the model was not super robust. So the reviewers in this case, whose names I sadly forget at the moment, really bumped up the legitimacy of this model, in my opinion. So in addition to the succession class mapping rules, the review of the descriptions and the models, we've also put together a new biophysical settings delivery system. You will be able to get the full package of models and descriptions at landfire.gov. If you don't want the full packages, you can go to landfirereview.org, a website that we'll send you later, and do a more sophisticated search based on words, or geographies, or you can filter by vegetation types. So this will be a lot more user-friendly, we think, than we had in the past. So I wanted to go over just a couple quick examples. I see a chat. Let's see, I'll look at that really quick. For one thing, the Forest Stewardship Council certification has several indicators that you would think we wrote. They fit perfectly under LANDFIRE sorts of data sets. For example, in Principle 6, there are indicators that talk about the need to demonstrate an understanding of size class, succession classes, natural disturbance regimes, and that sort of thing. Below are some charts that I drafted up for the Ottawa National Forest that demonstrate this sort of thing. So on the bottom left, you see acres disturbed by the northern pine oak ecosystem in the Ottawa National Forest. So roughly 500 acres of surface fire in the Ottawa National Forest in their pine oak ecosystem. In this web app we put together, you can select different ecosystems and get updated charts. On the right, you see the succession class differences between the modeled historical in gray and the current succession classes in green. And as expected, you see a dominance of the late, I think this one's a closed class succession class for the boreal acid peatland. Again, another online web app kind of report that we generated for the Ottawa National Forest. So I'm going to try to escape here and jump into a couple more applications that I wanted to show you. With the model outputs, we're able to look at ecosystems and their disturbances in interesting ways. So this is a core diagram for the top biophysical settings in Michigan. What we're able to do is say, hover over the fire part of the chart and see, there was 850,000 acres of fire annually in Michigan for these major ecosystems historically, and then explore by following the bands which ecosystems that disturbance is attributed to. Or we can hover over an ecosystem and look at the dominant disturbances. So with the outputs from the models, the biophysical settings models, we're able to do this sort of work. And it's super useful. I mean, I make this chart, I'm like, wow, we probably really under-modeled insects for Michigan. I need to look into that. Another thing we can do is compare past to present. So this is a dashboard that I'm working on for the Historical Museum in Marquette, where I live. And they wanted to see how different ecosystems have changed over time. Here we can hover over an ecosystem and see what it's changed to currently. So on the left are the historical percentages of the ecosystem, and then on the right are the current percentages. This is the sort of thing we can do with LANDFIRE biophysical settings data. And so with that, I think I'll stop, hand it over to Jim, who's going to wrap things up and open the floor for questions.
Jim, are you muted? Oh, there we go.
I am, and I'm unmuting as we speak. So thanks. Okay, I'm going to try to wrap this up pretty quickly so we have time for questions. Again, Amanda said at the beginning, I would stay on as long as there were questions. So if you can hang on after one and have an important question, then I'll be glad to try to answer it. Okay, so let's talk about take-home messages. Okay. So LANDFIRE products, remember the 4 C's. I won't say them again, but they are very important for you to remember as you utilize these products. Remember that they are designed for use at large landscape, regional, and national scales, but they also can be modified for local use, and tools have been developed to help with that. We have videos on our LANDFIRE video YouTube channel that help people review and modify the data. So we expect that you might need to do that because of the application scale of the products as delivered. We want to support you in modifications for local use if that's something that is important to you. The Remap product did incorporate new processes and data sets that we believe improve the usability of the products, and that represent mostly conditions in 2016, but also 2019 and 2020 for the surface fuels. We believe that the products are better, but we certainly need to hear from you about what you see and what you find works or doesn't work, because the feedback that we received originally was critical to everything that we've done in the Remap. We don't want that to stop now. We want that to increase. We still want to receive plots. We'll find some way to use those plots. They are critical to not only creating products, but also assessing them. So if anything you can do to provide us information, we still want to hear about it. So hopefully that you'll try some of these products, you'll download them, you'll give them a look, you'll provide us some feedback on what's working and what's not working for you. So feedback can be sent to us in many ways. You can go to the main website, the landfire.gov. There's a contact us page on landfire.gov. There is a help desk at landfire.gov, and that goes to a help desk who then distributes those questions to whoever they think might be able to answer that question best. Feel free to contact Inga, Randy, or myself directly if you have any feedback or any suggestions or any concerns, or anybody else that you know through the cohesive strategy or the National Association of State Foresters, or however you want to pass that on. Please pass on any feedback you receive. That's critical to us improving in the future. You can learn a lot from LANDFIRE online. Of course, there's the program website, which you see at the top. TNC maintains a science website called Conservation Gateway. And if you go there and search for LANDFIRE, we have a lot of information there about applications and uses, particularly for conservation, but not exclusively. we can certainly provide you some examples of how LANDFIRE products have been used. We have a Twitter site, which you can follow. We do tweet a few times a week, not a lot. We don't try to overwhelm you with tweets. We have a video channel on YouTube called LANDFIRE Video, all one word, which has 20 or 30 or so videos on there, many of which are how-to videos to help you do certain tasks. If you really want to keep up with LANDFIRE, the way that you can do that is through the LANDFIRE monthly postcard opt-in. We do only send that to individuals who have opted in to the postcard. Comes out once a month. It's not very long. It connects to a lot of other resources, but it should be something, if you're interested in keeping up with LANDFIRE, about releases, about product alerts, about applications, about stories, etc., then please opt into the postcard. And I think Megan's going to try to provide a way to do that at the end of the webinar.
Yep, all those are in the
Sorry,
chat window right now.
All right, so please opt into that postcard and learn the latest about LANDFIRE on a monthly basis. And we do only send that out once a month, so we will not overwhelm you with spam. And the last place, of course, TNC also has a LANDFIRE mailbox. So if that's useful to you, we're certainly happy to check that mailbox as well and reply to your questions in that mailbox. So I think that concludes the presentation. So now I'm hoping I can answer questions for everyone.
Great, thank you so much. So we do have some questions. We have one question that came into the chat window, and of course, the chat window disappeared as soon as I went to look for it. There it is. Okay, so Henry was asking, so it says, sounds like some good improvements with Remap based on new data and feedback. What if I still see issues or concerns with data from my area? What can I do to help highlight or address these issues in a way that is useful to LANDFIRE?
I'm not sure that I understand that question. I don't know. Henry, can you unmute, or can he unmute Amanda?
He can't, but I think he's looking for, if he's looking for ways to help continue improving LANDFIRE, how does he get in touch? I think that's the question.
Yeah, the key thing for us is feedback on what you see in the products. And you can contact us in any of those ways I showed, through the landfire.gov website, through any of the emails, etc. We'd certainly like to hear from it. But what LANDFIRE needs is good geo-referenced plot information, because that's what drives the mapping process. That's what helps us improve, as well as annual disturbance information. So if there are insect attacks, if there's wind throw, if there's disease, if there's fire, providing those disturbance polygons, if you can, with severity, if you can, will really help us update the products more quickly, as well as more accurately and completely. So those two things are key, really, for helping us improve, especially the products we're going to create in the next 2 or 3 years. But any information you have, feedback, plots, disturbances, we welcome hearing it.
Great, thank you. And thanks, Henry, for the question. Folks can type other, oh, go ahead.
Yeah, I just want to say, like, typically we say, well, don't look at your favorite pixel, right? Because there's some variation at the regional scale. But I would encourage folks to look at areas they're familiar with and see if it makes sense, you know. So, you know, a typical vegetation type that you hang out in, or you hike in, or you work in, check it out. Does it look great? If it doesn't look great, contact us and we'll figure out what the problem is and try to address it in our next versions. So definitely, like, if you have an area that you're like, this doesn't look great, like these canopy heights are totally off, or, you know, things like that, definitely don't hesitate to contact me or whoever from the LANDFIRE team. And we do have a tracking system. So if you email our help system, that request is not going to get lost. We will figure out some resolution for the issue.
Great, thank you. I do want to just mention, I think, Megan, this would be a great time to launch the poll. So we just have a quick poll to help LANDFIRE improve their user data and these webinars and other presentations and tools. We are going to make a hard stop at the top of the hour, but again, Jim is happy to stick around and answer questions, so keep them coming. In the meantime, Megan asked, what is plot data? What if my data doesn't fit your standards?
Okay, so LANDFIRE will take any plot data you have, but the key criteria for plot data is it must be georeferenced. It doesn't do us any good if we don't know where that plot is on the ground. So the plots must be georeferenced. But any sort of, even a vegetation call on a plot is useful, where you would just say, no, this is Central Appalachian dry oak pine, you know, not Appalachian pine hemlock or whatever. That's helpful. But the most helpful thing is to have a georeferenced plot that has detailed vegetation information on it. What species are present? What size are they? How many of them are there? The more information we can get about what vegetation is contained on that particular plot, the more we'll be able to use it. Okay, so it doesn't have to meet our standards. There is a, on the landfire.gov, there is a contribute data webpage on there that will give you sort of the criteria that we look at and that we use, but we will accept anything you have and try to use anything that you have. Old, doesn't matter, we'll at least look at it to see whether or not it's useful. So go to contribute data on landfire.gov and you'll see some specific criteria there. But be inclusive, you know, send us what you have and we'll evaluate it to see whether or not it's useful to us.
And speaking of using data, Nan asks, is there any way to get this data into a handheld device or iPad? That way we could give this to all the local fire districts, so when they go out to do inspections to drive around their districts, they can directly provide input into the handheld device.
And Inga, you can correct me if I'm wrong, but I do believe that some of that information is mobile friendly, but I'm not sure what on the website. I've never tried to download data on a mobile device, so I'm not sure how that would work, whether you download to the computer first and then pass it to the mobile device or what, that I don't know.
Yeah, I think that would be the best way to go about it, because our viewer, although it will adjust for you know, the size of the screen and everything, our viewer is more of just you know, a computer-based platform, I would say.
And Nan says we did this in Boulder County.
It on a handheld device before. Yeah, we have used it on a handheld device before out in the field. So I know it can be done. I'm sorry, I just don't know the technical process.
All right. Unfortunately, my clock says 2 o'clock Eastern time, which means we need to let people go. But please join me in a virtual round of applause for our presenters. And again, if you have questions, please feel free to stick around and ask questions after the whistle. So let's see, Chase asked the question, is this data available as web feature services?
There are REST and WCS services for LANDFIRE spatial data, which you will find on landfire.gov. And so there's also future work on feature services going on in the fire community that LANDFIRE will be a part of. But right now it's available as a WCS or a REST service today, any of the spatial data.
Great, thanks. You're getting a lot of thank yous coming into the chat window. I have another question. So regarding LiDAR data, how much, I guess, what percentage of the region is covered, or was LiDAR data updated and had input into the remap?
That's a good question. That we need somebody else to answer that one, Inga. Maybe you can.
Yeah, I think it's a good portion of the Northeast area was covered. Yeah. I don't remember any big gaps when looking at the LiDAR coverage. I guess the other
exciting
mention was any kind of disturbance data or events is also something that we would love folks to continue contributing. So things like mechanical treatments for different polygons, any kind of insect damage that you're keeping track of, you know, and of course your prescribed fires are all very, very important for us to pull in terms of our disturbance data.
And I'll weigh on that too and say how critical that actually is to the future update processes. If you want us to turn around information quickly, you need to tell us about it. I mean, you can't count on us finding it ourselves, not consistently and not accurately. We will try, but the best thing to do is to send it. I don't care if it's 5 acres. I don't care if it's 1 acre. Whatever it is, if you'll send it, we will use it.
Yeah, and this I think is especially important in the Northeast because we don't have those federal, large federal databases that we do for a lot of the country. And so having that state level data, county level data, that folks are submitting is more important in the Northeast.
And you will find information about submitting that information also in the contribute data section on landfire.gov. They do have some sort of processes that you might do what's most helpful. So you can look there certainly, but whatever it is, send it. We'll try to use it.
Great, thank you.